So the way I'm going to approach this conversation is use modularity, right? And modularity of a system is not, it can be looked at different levels of abstraction. You can have a very highly modular monolith, and the term is usually used when certain big fat jar or a big fat mud of ball, as it is often called, is used for deployment, versus in a service oriented conversation you have more smaller granular units of deployment. That's probably one very agreed upon way to distinguish them. Other would be that everything is within a part of one large system, one large build system. The system builds as a whole, there's interdependencies, but in a microservice ways there's intradependency. So we are going to approach this from a modularity perspective, and I'm going to bring in my thoughts into it. So here we go. So monolith, service architecture, and microservice, and I think it's very very important to bring in the service architecture between, because that gives a lot of conversation enabler. A lot of people who have recently started their careers, who have only seen the world of REST based API, they have not looked at service oriented architecture from a first principle basis. So I think one very good definition, and I'm referring to architecturenotes.co website, where I could find some really nice visuals around it. So love the visuals that the creator of the website has done. So monoliths are large single unit. SOA, or service oriented architecture, talks about services, not as granular or as fine grained as microservices, but more at a service level. And this can be thought of by a very simple example. Let's say you have an order management, payment management, invoice management systems. If all of these three are combined as one, you would call as monolith: invoice, payment, order, right? In SOA you would have them as separate services. Now let's imagine that the order, invoice, and payment, each of them are doing multiple methods, get, post, delete, etc. What you could do is, basis some argument which could be correct or valid in that scenario, you might want to break that service even further. And this is a technology way of decomposition. There's other ways of decomposition as well. You could go by the number of database objects you are interacting with. That's one way to look at it. So typically when you go from that level of granularity to further down, you get into microservice world. Now we have looked upon monolith and SOA and fine-grained. Let's take a look at what are the pros and cons for each of them, and then we'll go to the modularity conversation. So I think personally speaking, monoliths are a great way to start, very fast from a development standpoint. They can have a good degree of performance as long as it is not a large monolith, as long as you are not serving hundreds of millions of users. Even then it does hold a value from a code base perspective, but it becomes a bit difficult to maintain. And there are definitely fewer cross functional concerns. The cons would be, as I was saying, as the size grows, as the complexity grows, the agility of the system goes for a toss. And as the system becomes large, they are resistant to changes. For example, you have a new developer coming in and he or she would say that, hey, I don't know what this part of the system does, but it has not been changed for 5 years. Now that is a true statement in a lot of cases, and something which has been sitting there for that long, people are usually very afraid to touch. So that's one big downside of monoliths. And let's venture into the world of service oriented conversation. So service oriented are fine grained, so they are more service focused, and they have a better maintainability, testability, usability, and you could thereby having more agility in the system. Also, you can have multiple people who can work in parallel in the same system. I think this can be true in monoliths true also. However, it's very difficult to do parallel testing, parallel development if you have a single branching strategy, and so on and so forth. With services, I think the way they bring modularity to the table is just good. So I love the middle ground conversation that services bring to the table. Overall response time, increased coordination, and a larger planning, and these are more cons. So one downside is as you move from monoliths, which is just one deployment, to multiple service, what is happening is that instead of your code directly dependent on a certain module or a function or a class within your system, what's happening with the service is that your service is dependent on some other service, right? So the dependency hasn't gone away. It has not been removed, though there are ways to do that. You can find different ways of interaction. You could make the transactions completely independent and isolated, but that requires a more deeper design thought into the system. But overall, the dependency hasn't gone. It's maybe just calling an external system. So there's a lot of interactions happening in the system, so it can also lead to certain failures in the system. Let's say one service is down, it would fundamentally disrupt the system in a different way. Now this is both pro and con. Now microservices are, as I was talking, even more fine grained. Let's look at what the definition is, right? Definitely ease of development and testing. As you go into more further granularity, they are you define by user needs. For example, I'm building a website or I'm building an app where we are doing order management, payment processing, and invoicing. Now I know that invoicing and payment processing comes after order management, and even within order management, I know people see my products more than buy them, right? And the ratio is like 90 is to 10. If there are 100 people, I know only 10 people buy it. So it does make a lot of sense to decompose them from a scale and performance perspective, because now think that if you want to scale just that part of the system, you can take that and distribute that across multiple nodes, cluster based architecture, which is effectively getting into a better distributed design. So I think they bring a lot more agility to the table, but the downside is a very high degree of increased complexity. The number of interaction that microservices end up is basically very high from an operational perspective. So that's what this amazingly summarized view of website is talking. Let's move on and take a different stab at it. So what I did is I was attending a meetup sometime back, and I loved a 2x2 conversation anytime that happens. So somebody did a very nice 2x2 depicting a monolith and a microservice. I think their argument was that in an eventual scenario, you go to a microservice kind of a setup because of the needs and as system grows. So I'm just trying to tone it down and bring the thought there. So if you have modularity on x-axis and complexity on y-axis, complexity on x-axis and modularity on y-axis, we can safely put small monolith as the least modular and least complex system. That's where you want to start. Now this 2x2 gives you a great way to decide where you are headed. If your use case is new, if you are a young startup, if you're trying to prove a point, if you are doing a POC, if you are doing a simple B2B business with few hundred users, don't worry about and don't bake complexity into your system, right? And you can even bake a little bit complexity into the system by adding modularity. So if you just add more modularity in the system, your system becomes a little better. So it's a more modular or a high on modularity, low on complexity is where you want to achieve if you are a B2B business and things like that. Vis-a-vis, if you have a large monolith which is not modular, this is a recipe for disaster. So this gives you effectively the direction to move. So okay, let me select pen, sorry. So don't go in this direction, definitely go in this direction, and definitely go in this direction. So you want to do this and this, but not this, right? So large monoliths should be avoided as a general principle. But eventually, if you have a good handle on the number of modules you have built on, and it's very nicely modular code, nicely the design principles patterns have been followed nicely, database interactions are nice, you are maintaining the asset transactions, you are able to keep the sense of the system sane, you are able to deploy it, you are able to do faster releases, you have a great and excellent test coverage, you are kind of deploying every 2 weeks. So That's a very rare state to be in, but if you have been able to achieve that, kudos to your teams. But this 2x2 gives me a great picture and a great way to think about it. So yeah, that's what I wanted to talk about.